On this video, we're going to talk about slope field. Before we get into slope field, let's review about slopes. When you have a vertical line, the slope will be undefined. What about when slope is 1? That means you go up 1 and then move right 1. So the line will look like this. What if the slope is 2? That means you're going to move up 2 and then move right 1. So it's going to be steeper. If it's 5, it's going to be even more steeper. So I hope you get the idea. What if it was 1 over 2? 1 over 2 means you're going up 1 and then move right 2. So it's going to look like this. Okay? What about negative 1? Negative 1 means you go down 1 and then move right side 1. So it's going to look like this. And so forth. So I hope you get the idea. What if the slope is 0? Well, it's going to be horizontal. Horizontal line. That's m equals 0. So now let's say you have y equals x squared. At 0, slope is going to be 0. And over here at that point, the slope of a tangent, small segment of tangent line will look like that. At that point, small segment of a tangent line will look like this. So when you repeat this process at every point, we're getting the slope field. So this is the idea of slope field. So when you want to construct a slope field for dy over dx equals cosine x, well, you first need to graph x and y axes. And notice, whenever x equals 0, what is cosine of 0? 1. And what is the slope of 1 look like? Well, it's going to look like this. Okay, it doesn't matter where the y value is, because as long as x equals 0, it doesn't matter what the y value is. Slope will be dy over dx is 1. What about at, let's say, pi over 2? Cosine of pi over 2 is 0. So whenever x equals pi over 2, the slope field is going to be 0. Okay? What about pi? What is cosine of pi? Well, cosine of pi is negative 1. So at pi, it doesn't matter where the y value is. It's going to be negative 1 when the x is pi. I mean, you could repeat this process and get the slope field for dy over dx. Now, what's interesting is this. When you follow this slope field, okay? When you follow the graph of this slope field, now what does this graph look like? Does it look like y equals sine x? Notice, what is the antiderivative of cosine x? It's sine x plus c, where c is any constant. That's what's happening. When you follow along the slope field, you will get the solution curve, graph of the solution curve. And if you want to get a particular solution of a solution curve that goes through that point right there, all you got to do is follow along the graph that goes through that point. Let's say you want to sketch the slope field of dy over dx equals x plus y at these 9 points. Well, all you got to do is, let's say over here, you got 0, 0 over here. And plug in 0 for x and 0 for y. So 0 plus 0 is 0. The slope will look like this. What about 0, 1? Well, 0, this point over here is 0, 1. So 0 plus 1 will be 1. So it's going to look like that. What about over here? It's 0, negative 1. So it's going to be negative 1. Okay, what about 1 and 1? 1 plus 1 is 2, so it's going to be steeper than 1. Or over here, that's 1 plus 0, which is 1. And over here is going to be 1 plus negative 1, which is 0. Okay, what about over here? That's going to be negative 1 and 1, which is 0. And that's going to be negative 1 plus 0, which is negative 1. And negative 1 plus negative 1 is negative 2, so it's going to be steeper than negative 1. Okay, so that's the idea, how you sketch slope field.